My name is Varun Ganapathi. I'm the CEO of Terminal.com. Terminal was started after I left Google back in 2013. So prior to that, I was a PhD student at Stanford where I did a lot of machine learning and computer vision. I started a company which then became part of Google. At Google, I did a lot of machine learning and computer vision as well using their infrastructure. And what I found is I felt that there was a way to make a better infrastructure for doing machine learning in particular, a better cloud that was focused on just machine learning and data science. So Terminal.com is our startup that's trying to make everything a lot easier to do for data scientists. So when you go to Terminal.com, what you see are a bunch of snapshots. So you can go to any one of these, and these are snapshots that are published by users. You can start them up, and when you start them up, they come up in about 10 seconds usually. When you get to one of them, I'll just show you an example of starting one up. You just click the button, and then you click start. And in the background, this just happens. I'll just switch over to another view where one's already started up to save time. Once you start up the terminal, you get to a page like this. This is an IDE in the browser. On the right side, you'll see I have IPython Notebook already started up and running inside this terminal. What's really cool about terminals, as opposed to normal VMs you might have experienced in other clouds, is that a terminal retains its RAM state when it starts up. So what that means is that all processes that were running when you start up when you took a snapshot remain running while you're in the terminal. And this gives us a lot of cool capabilities as well. So I'm in this terminal. I can, it's like a normal, fully functional terminal. You'll see up here, I don't know if it's too small. I'll just make it bigger. You can see here, this is the amount of RAM I have on this terminal. It's not very much, 262 megabytes. So let's say my program needs more RAM. What I can just do is go up here and live update the RAM or the disk or any other state about my terminal. Click save, and in the background, terminal makes it happen. And so when I hit top again, you'll see that you have way more RAM now. It's 3.2 gigs of RAM as opposed to 256 megabytes of RAM. So what was really awesome about that is nothing has changed in my computer. So I'm just working. I realize I need to compile something, or suddenly I realize I want to do a parallel job inside my IPython notebook while I'm running it. I can just do that without having to, freeze an instance or start up another instance, copy all the data over, all of that stuff. I don't have to do that. I can just literally just resize my machine while I'm using it. And of course, you only pay for the time that you're using the bigger instance, so you don't have to pay for it when you're not using that. Then when you're done, you can just say, okay, I want to shrink back to a micro. And it just happens in the background as well. So basically, you have a computer that you can just resize anytime you want. Its resources grow as you use it. And you can just, when you're done using it, just like your own laptop, you can just pause it. And so I'll show you that as well. When you go to your list of terminals, every time you start up a terminal, you have a page here that has a list of all your instances. I, of course, have a lot of them. You'll notice some of these say pause next to them. So what I can do with the one I was just using is I can just hit pause here. Whoops. I can hit pause here. And it will pause. And this pause is not like a shutdown. This is actually just, it's like standby. It's like closing your lid and it's paused. And then when I click start again, it's exactly where I left it. So I can do that. And when it comes back, you'll see that all of the processes I had running, everything is exactly the way it was when I left it. I find this to be a much easier way to use the cloud than any other approach. So I think I actually paused and resumed the wrong one, but you get the idea. Another really cool thing you can do is publish snapshots, which is what we encourage people to do, because one problem I found in research is that it's not very reproducible. In theory, code makes it so that you can totally reproduce anyone's research, but in practice, managing environments is difficult, and oftentimes you lose the exact, the operating system or what libraries I had installed, all of that stuff can get lost while you're doing your work. So with Terminal, what you can do is just snapshot your instance while you're running it, and everything is exactly the way you left it. To demonstrate that, I'm going to start up a Python server on port 8000, and so it'll start up here. I'll pull it up in the browser that's built in. So you'll see that server is running on this terminal. And what I'm going to do is snapshot this while this is all happening. It has the actual everything is running. Is that easier to see or harder? Maybe it's harder. While it's running, and I can basically just give that snapshot to someone else, and when they start it up, they'll be in exactly the same state. So it's starting up, text by the bay. Cool, that happened. So now the snapshot is published. When I start up the snapshot, it will be exactly where I left it. And so that's the basic paradigm, is that we make it possible to essentially very quickly create a URL that uniquely identifies the state of your entire instance, including its RAM, and then be able to share that with other people, and or just for yourself, where you can go back and say, okay, what was it like right at that moment? Okay, I can go back and compare like what happened, what was different, what was the same. And the snapshot includes all of your data as well. So if you have a bunch of data sets loaded into the terminal, that comes along with the snapshot, and it's copy on write. So therefore, if you modify the data in one of the snapshots, the original data doesn't get affected. So I find that to be extremely useful for just keeping track of your work. It's sort of turning your entire machine into a document that you can just very quickly start up copies of. The internet here is a little not as fast. But one more example, I wanted to show you another cool feature, is for pair coding, terminal is really useful as well. So if I pop open, if I can share a link to my terminal with someone else, and we can both be in there at the same time. So I'll show a demo of that. So I'm creating two windows. We're both in there at the same place, and we can both just collaborate. So say you need help with something from someone who's not even on your coast, like someone far away. Actually, we use this feature even when we're in the same office, which is a little weird. But you can just simultaneously code in the browser at the same time. You know, it's simultaneous editing. Everything works. So basically what that means is that you can basically pair code together right in the browser with just sending a link to someone, which is really useful. The way you control that is by setting permission. So you can say, okay, I want this person with this email address to have access to my IDE. Or you can even do it on just a port. So for instance, I can say, I just want to make this one port available to everyone. Once you do that, now it's on the web. Anyone can go to it. Right, so I can show that example right here. So you now have an instant website running from your terminal, shareable from anyone. Anyone can go to it, or you can share with specific people. So that makes it really easy to work together. For instance, if you're working on the same IPython notebook, you can just send a link to your terminal with the IPython notebook server running and just use it. Terminal has a lot of other cool features, but first let's just go back and look at that terminal that we had that I started up to show that it was exactly the same state. So if you remember, this one is text by the bay. This is the snapshot I just made. When I go to it, it'll be in exactly the same position that the other one was in. So we'll just wait for the internet to get us into it. So you'll see the server is running, and the tabs will reload exactly where you left it. You'll see the server is exactly where you left it. So if I hit this again, it will just update the same one right here. Yeah, so you'll see that happen. So basically, it's a very flexible way to start up instances, do whatever work you want to do in them, snapshot them, and share them. So people have created a lot of really cool ones on terminal. This one is a really interesting one. It's a VNC client, a web-based VNC client. So literally, this is a browser running inside a browser, running inside a terminal. You can just, we can even go another level down and go to terminal itself here. Oops. And so now I'm using a browser that's in the cloud from my browser. You may not always want that. But what's really cool is I can share this link to someone else as well. And then now we both have a live session to the same exact web desktop. So two people at the same time, we can both scroll. We can both use a browser fully with all the graphics and everything right away, which is really useful for a lot of people. So people have shared a lot of snapshots on terminal for machine learning. One really cool one is Prediction.io. I don't know if you've heard of them or if they're giving a talk here. They basically made a snapshot that has everything ready to go. So you can basically start up a movie recommender on terminal in 15 minutes. You just start up their snapshot, and it has everything baked into it. It has a data set. Everything's ready. And what's really cool is once you've started that up, it's already a web service. That means that you can use it from your other terminals or from any server on the internet. So you can basically just spin up a machine learning tool for you running on terminal and hit that from anywhere, which is really useful. This video we're going to put on our blog so you can see it. They basically demoed this at our meetup a few weeks ago, and they keep updating it. There are some other more specific experiences we built. So for IPython Notebook, when you publish a snapshot, if you snapshot a terminal that has a notebook running in it, we can just go into the terminal. Have you guys all used IPython Notebook? Have you heard of it? Yeah. So the creator of IPython Notebook is actually an advisor for terminal. So he's helping us make IPython Notebook work really well on our website. So what's really cool is when you snapshot a terminal with notebook in it, we capture the entire state of that notebook and just publish it along with it, so people can go and look at that. And when they start it up, they'll be exactly where you left it. So I can switch to the notebook one to show that here. Yeah, this is the one with the notebook. And what's cool is you'll notice, like, when I start it up, the RAM state is present, right? So that means that when I press enter right now, it's exactly where it left it. So let's see, we can run all and so on. So essentially, what we're trying to do is just make the cloud much more easy to use, much more flexible. You don't have to be a sysadmin. You don't need to be an expert in EC2 or something to use it. It's all accessible in the browser. If you want to SSH in, we provide that as well. So there's nothing, you can use it just like a normal cloud instance if you want to. And finally, I'm just going to show a bunch of snapshots that people have published that are machine learning specific. So we have an Octave IDE. It's basically MATLAB, but it's the open source version. You can also install MATLAB in a terminal yourself if you wanted to, if you have a license for it. We have an RStudio server terminal, which is really nice. They have a really good IDE themselves, and there are a variety of other ones already present. So for all of these things, you no longer have to spend a lot of time getting it set up. You just click start, and everything is ready to go. That's pretty much all I wanted to say. Just present how you can use terminal to make machine learning easier to do. Thanks. Do you have any questions? Oh yeah, it's all root. You have a root, it's just Linux. Yeah, you have full root access. There's nothing weird about it. You can apt-get install whatever you want. I can show an example. I don't know if this is Yum right here or apt.
But once you turn it off, you can read
No, it's full state, hard drive state, everything. So the entire machine state is kept. So it's just, you can treat it just like a regular Linux box if you wanted to. You don't have to think of it as anything special. One small thing, Stanford class used Terminal to do their GPU deep learning on GPUs. Terminal has GPU instances, so when you spin one up, you can get a GPU right away and then pause it and resume it just like you would with anything else, which is really useful.
You say something about credentials to data like an S3. Is there a way to not persist that stuff so you can be handing people most of what you have in the terminal, but not
all of it? Yeah, that's a great question. The credential issue, one obvious way to do it, of course, is you can just remove the credentials from it when you're in there. Another trick you can use is start up another terminal that just acts as a proxy. So it basically is actually the one with the credentials, and you just talk to it when you want to get access to data. So we've done this. We have another thing called local terminal where we use this feature ourselves, where you can download any of these terminals and run them on your own computer. I forgot to mention that. So you can just click download. It takes that entire state, runs it inside VirtualBox on your own computer, and you can still use it using the browser or whatever. So you can work locally. But that's a tangent. What you do with that, a second terminal, is you just ask it to have S3 generate a temporary URL. That URL will only be valid for a certain amount of time. Then that URL you give to whoever you want to access your data set, and then they'll be able to download it.
So if you're hosting your own large data sets on S3 and they're private, are you pulling data out of the S3 data center, the AWS data centers into a different data center?
No, we run on EC2 ourselves, actually. So we're going to launch on more AZs, so you can pick one that's closest to your data set. But one cool thing about running on EC2 with S3 is that the data flow back and forth from S3 is free. So that's really nice. So essentially, you can think of this as just making EC2 like way easier to use, and you can just run it. There are also users who took Terminal. They don't want to run it on our public cloud. They run it on their own EC2 and VPC themselves. So you can literally just take our software with all of the container management and everything that we've built into it and run it yourself for your own stuff. I just use the word container just to clarify these are not the same as Docker containers. As you know, Docker containers don't have RAM state. They don't have all of these features, and they're not, I guess, as secure. Nothing's perfectly secure, but these are sort of hardened containers that are designed to be used kind of like entire Linux boxes, not as just for an app container.
May I ask another question? So if I have a large instance and I read, let's say, some negative file into the data frame, and then I want to downgrade to micro, but the amount of RAM available is less than what I'm sort of currently using,
What?
are you throwing some error, or how are you doing something like that?
So currently the way we handle that is the same way Linux does when you run out of RAM, which is that it will kill processes that have too much RAM. So essentially it'll just start killing things to get itself down to the appropriate amount of RAM. We could throw an error, but
Or not an error, but like a pop-up window, like, hey, by the way, we noticed that in your users, space, you're using more RAM than you're going to have.
so we do that for disk. We could also do that for RAM. Speaking of which, this just explains one reason why we didn't do that, but we could maybe put it in some way, is we have a thing called idle settings. It's basically like power management for your terminals. So what you can do is configure a terminal that when the CPU load is less than some amount, or when it's been accessed not frequently, it should just pause itself or micro itself. So it'll just turn into a mini instance. So that can be configured to happen automatically. So you don't run into this problem where you forgot to turn off your terminal and now you're just losing tons of money because you just left it on overnight or something like that. It protects you against that. One other point I forgot to mention is an API. All of the stuff that's here is accessible through a REST API. What's really cool about the REST API, we find people using it, is that they'll automatically start up a terminal and run a script inside it just for the purpose of like running a job, essentially. So you can just use terminals as a way of spinning up jobs in the cloud, having them run, and because they automatically pause, they can just go to sleep when they're done, and you can go check them later. Or, of course, you can publish the result of the data set to S3 or something and then kill the terminal off. So basically, this API, you can find it on the API docs. We made it really easy. You can just try it out right here. It auto-generates the code you need to actually use it. So here are some examples. You can say what sort of snapshot you want to run. That's an ID from the snapshots page, and that can be a private snapshot. You tell it the instance type, and then you can say, is it temporary or permanent? Should it have auto pause, meaning like should it go to sleep automatically when it's not doing anything? And then the most useful probably is a startup script. So you just give it a script, and when it starts up, it will just run that script automatically by itself. So you can just spin up tons of jobs in the background, have them run, and get access to them later if you want to. Any other questions? Great. So if you have sensitive data sets, we recommend using the private cloud version of Terminal where we run it. It depends on who is regulating you, right? So some regulators say that it has to run in, for instance, a HIPAA compliant data center, right? And in that case, we're using EC2 under the hood, so we're standards compliant because EC2 is standards compliant. But say it has to be in the government cloud version of EC2. You can just start up your own terminal, like or entire website basically, for your own company just on your own VPC. And what's cool about that is Terminal will take care of behind the scenes spinning up additional machines for you and killing them off when you're not using them. So effectively, it's sort of an auto-growing and shrinking cluster that you can just run inside your own cloud for yourself. For the software, for that software, we've been doing it on a personal basis. Like people contact us and we talk to them, because we offer support along with that to help you actually use it. And of course, the same thing can be done on your own data center. So if you happen to have physical servers, I don't know if people do, but if you have physical servers, you can do the same thing. You can just install Terminal solution on your cluster locally, and then just use all of our features, but just in your own cluster. So other people have been using Terminal in that way. Cool. Any other questions? Okay.
Specific libraries, can you create terminals specific to a particular operating system and no specific libraries?
Yeah, so I'll show you the base snapshots. So we have all the normal base ones available. If you go to base OSs, these are ones published by us. These are clean. So essentially, official CentOS 6, Ubuntu 14.04, Debian 7, And if there's one that you want that we don't have, we can just create that for you, or you can even create it yourself. So you can start from this one and then just install anything you want, like get it all set up, ready to go. I did this for myself for GCC 4.8 and Thrift and all this stuff. It was a nightmare to install all of those. So I just, exactly. So I just snapshotted it and everything was ready. I have another one for doing kernel development. So what's really cool is you can just create these environments, pre-bake them with everything ready to go, and then just snapshot it. And then this is really useful, especially on teams, because one person can set up the dev environment and then just give that URL to everyone else. They can start it up, you know, git clone the code and then just work and not have to deal with all the library management.
So in the case of like a GPU AMR,
Yep.
so you're starting up some GPU EC2 instance, and then for some reason the user decides to download the virtual box. Does that work?
Oh, great question. Yeah, so there are limits with the GPU ones. Your VirtualBox has to have access to the GPU. That may not work. It depends on your local setup.
Let's say on my dev machine, I actually have an NVIDIA GPU.
Is your dev machine Linux or not? Okay, so with Linux, the cool thing is you can run us natively. You don't need to run VirtualBox. You can just run terminal direct natively on Linux, in which case it will just work. What we do,
So I would need to have like the GPU drivers and everything installed.
yes,
the same way.
on the host. So you have it installed on the host. We mount access to those devices directly into these environments. So it's totally native speed. There's no overhead associated with that. So on Linux, it's really great in particular. Yep. Great, I'm done? Okay. All right, thanks.